Imagine a giant ball of fire so massive that it powers life on Earth, holds the entire solar system together, and yet it's just one among billions in our galaxy. Today, we are diving deep into the star that's literally at the center of everything, the Sun. From its explosive birth to its fiery future, get ready for a journey that will blow your mind. Let's begin. 4.6 billion years ago, the Sun was born from a giant molecular cloud of gas and dust in space. Gravity pulled these particles together, creating immense pressure and heat at the center. Eventually, nuclear fusion began, and voila! The Sun ignited as a shining star. Our Sun is currently a main sequence star, meaning it's in the prime of its life. In the grand scheme of the Milky Way galaxy, the Sun is just a tiny dot located in the Orion Arm, about 27,000 light-years away from the galactic center. Within the solar system, the Sun is, of course, the heart. Our planets revolve around it like clockwork. The Sun is primarily made of hydrogen, about 74%, and helium, 24%, with trace amounts of other elements like oxygen, carbon, and iron. It contains an estimated 10 to the power of 57 atoms. That's a number so big it's almost impossible to imagine. The Sun has 6 main layers. First, the core, the powerhouse where nuclear fusion occurs. Next, the radiative zone, where energy moves outward as radiation. Then the convective zone, where heat is transferred by convection currents. Fourth, the photosphere, the visible surface we see. Fifth, the chromosphere, a thin reddish layer. And finally, the corona, the outermost glowing halo visible during solar eclipses. The Sun's surface temperature is about 5,500 degrees Celsius or 9,932 degrees Fahrenheit, but its core, a mind-blowing 15 million degrees Celsius or 27 million degrees Fahrenheit. The energy produced at the core takes thousands of years to reach the surface before it radiates into space. At the Sun's core, hydrogen atoms collide with such force that they fuse together to form helium. This process, called nuclear fusion, releases an incredible amount of energy, which powers the Sun and emits the light and heat we rely on. The Sun is about 109 times larger in diameter than Earth, and over 1.3 million Earths could fit inside it. It's also 330,000 times heavier, making it the most dominant object in our solar system. The Sun's gravity is 28 times stronger than Earth's. This gravitational pull keeps planets, asteroids, and comets orbiting, ensuring the solar system remains stable. Without the Sun's gravity, everything would drift into chaos. The Sun's magnetic field is incredibly powerful and drives phenomena like solar flares and sunspots. It also interacts with Earth's magnetic field, creating beautiful auroras near the poles. However, solar storms can disrupt satellites and power grids, reminding us of the Sun's influence. In about 5 billion years, the Sun will run out of hydrogen fuel. It will expand into a red giant, swallowing nearby planets, including possibly Earth. After shedding its outer layers, it will shrink into a white dwarf, a tiny, dense remnant of its former self. The Sun is the source of all energy in our solar system. It drives weather patterns, powers the water cycle, and enables photosynthesis, which sustains life on Earth. Even technologies like solar panels depend on its energy. So the Sun isn't just a star, it's the life-giver, timekeeper, and anchor of our solar system. As we marvel at its brilliance, let's not forget that it's a reminder of the incredible balance in the universe. If you enjoyed this cosmic adventure, don't forget to like, share, and subscribe for more fascinating explorations. Until next time, stay curious and keep looking up at the stars.